Does our universe truly exist entirely, or is it, at last, a short-lived second in an everlasting pattern of universes? Well, English physicist and Nobel Prize winner Roger Penrose knows precisely how to address this question. He is persuaded that the universe is subject to a never-ending pattern of obliteration and resurrection. Yet, that is not all. Penrose, as a matter of fact, accepts he has finally found strong proof for his repeating model. Specifically, the English researcher has identified a series of mysterious selling points in the microwave background, and thus, possibly the spots where the very large black holes of a past universe once dissipated. What is now essential for the fundamental knowledge of cosmology was, at best, a colorful thought around a long time ago. In fact, until the middle of the 20th century, most scientists believed that the universe was an everlasting, or at least constant, entity. Of course, stars could be born, die in the universe, planets could crash into one another, and human civilizations could prosper and die. However, on a huge spatial scale and over significant stretches of time, the assumption at the time was that the universe generally held its key appearance. But eventually, astronomers realized that distant galaxies were apparently moving away from the Earth, and that the speed of this cosmic expansion was even increasing with distance. Many detailed follow-up studies later, scientists finally revealed the real cause of these bizarre galactic movements. Strictly speaking, the galaxies are not traveling through space at all. No, it is perhaps space itself that is constantly expanding. In all, the scientists had realized that the universe is expanding, and the idea of a rigid, constant, unchanging universe had finally been abandoned. But it took until the 1960s before scientists understood that this expansion process, when viewed reflectively, leads to a super-unique phenomenon. Moreover, the universe appeared as a consequence of this, some 13.8 billion years ago, with the Big Bang. Such a radical cosmic upheaval had perhaps not happened since the realization of the heliocentric perspective. Despite the fact that we now know, of course, that the Sun is in no way the center of the entire cosmos, but just marks the center of our solar system, this, too, was a revolutionary insight. However, as so often happens, this groundbreaking realization was also linked to several significant questions. This time, if the universe truly was born in the Big Bang, what happened before that? What did space look like before it began to grow, and how long did it remain in this base state? Adding to this is the fact that, according to our understanding, everything that has a beginning also has an end. But what will the ultimate end of the universe look like? Roger Penrose, with his cyclic theory of the everlasting pattern of the universe, believes he has answers. Although these intricate questions are as old as the theory of how things came to be themselves, we have still not found any clear answers to them. Furthermore, in their theoretical contemplations, there is no real agreement among scientists. In fact, the field of cosmic research has long been split into two camps on this issue. Stephen Hawking, for example, believed that addressing the question of what was before the Big Bang is as mysterious as asking what may be north of the North Pole, since time itself only began with the Big Bang. Nothing could have existed before that. On the other hand, there are the views of Roger Penrose, a theoretical physicist. Penrose had already worked with Hawking during the 1960s, and with him, he contributed to pioneering breakthroughs in the field of singularities and black holes. In 2020, Penrose was again honored with the Nobel Prize in Physics, well, at least half of it. He received one portion of the award for the statement that the development of black holes is a strong prediction of general relativity. The other half went to Reinhard Genzel and Andrea Ghez for the discovery of a supermassive black hole at the center of the Milky Way. But if we now remove ourselves from the world of Nobel Prizes and return to the real subject, we see that the veteran physicist first approached the question of the origin and destiny of the universe from a more philosophical direction. First of all, Penrose wanted to define what constitutes a universe and what constitutes a non-universe. Ultimately, the conclusions of the English researcher can be summarized as follows. The first characteristic of the universe is movement, which in turn requires the presence of at least two material or energetic objects whose distance changes over time. However, if there is none, or only one of these objects, we are dealing with a restricted space that cannot be measured as such. It is impossible to say whether space is infinite or whether it has been compacted into an ultra-small volume, as in the case of a singularity. In this context, concepts like speed and time completely lose their meaning. According to Penrose, it can be assumed that the universe will one day return to such an extreme state from which it can explode into its new existence. In a very far-off future, the last elementary particle will have decayed, and the expansion of space will have destroyed the last photon. In this model, the universe will continue to expand until all matter has decayed and turned into light. This strange environment, where nothing has any time or space reference to one another, will ultimately make way for another Big Bang. According to Penrose, this is by no means an astronomical anomaly but an overall design that repeats itself over and over again. As mentioned at the beginning, Penrose is convinced that the universe has a cyclic nature, described by obliteration and resurrection. But if the timeless restoration of the universe is real, shouldn't there be some tangible evidence for it? Well, according to Penrose, it actually exists, and we have already found it. Do peddling points stem from a past universe? In detail, Penrose, along with Daniel and Christoph Meissner and Paul Mirowski, has identified a significant signal in the cosmic microwave background that should lead us directly to the true nature of the universe. Both the Planck and WMAP satellite data contain several round spots, with diameters roughly corresponding to that of the full moon. But what do such spots have to do with a cyclic universe, and why did scientists ignore them for so long? Well, essentially, the vast microwave background radiation, or CMB for short, is a remnant from the earliest days of the universe, created around 380,000 years after the Big Bang during the so-called recombination era. And indeed, the background radiation still fills the entire universe today. Since it was predicted in the Standard Model, its actual detection is considered remarkable proof for the Big Bang theory. In line with this, Penrose now believes that the location of the so-called H-locking points is strong evidence for the cycle hypothesis. Most importantly, the aforementioned spots correspond to multiples of the normal CMB temperature fluctuations. The Planck and WMAP data had identified these inconsistencies in the very same spots, and they had been ignored until now, since it was believed that cosmic expansion would have completely erased such features. A brief explanation: specialists refer to a period of incredibly rapid expansion of the universe following the Big Bang as cosmic inflation. While the inflationary burst lasted only a fraction of a second, it is believed to have expanded the universe by a factor of 10 to the power of 26 during that time. To put it more clearly, the region that today corresponds to the entire observable universe initially had a size much smaller than that of a proton. Then it suddenly expanded to a size of 10 centimeters. Cyclic models also know such periods of inflation, with the small but essential difference that they find them in the time before the Big Bang. In other words, inflation results from the dramatically expanding far-off future of a prior age, of a previous epoch of the universe. And as mentioned within the cyclic model, there is an endless series of such ages, each of which has its own Big Bang, marking the continuation or the dramatically expanding future of the preceding age. Strangely, the transition from one age to the next is permissible from both a mathematical and physical perspective. After all, the conformal pressure of the cold far-off future with low density matches with the conformal expansion of the hot, dense Big Bang of the following age. With one exception, on paper, the very large black holes don't adjust so easily to the next age. In fact, at the end of the universe, they would have completely consumed the galaxy clusters in their area before they themselves finally disappeared into Penrose radiation. However, because of the so-called conformal crunch, all the transmitted energy passes into the following particle in the form of a single Penrose point. The photons that are produced simultaneously disperse in an expanding region, but they are only released when they finally arrive in the microwave background radiation of the next age. Again, the corresponding region would appear to us as a disk the size of our full moon, and it seems that we can actually see such an effect in the CMB sky. In total, the mysterious spots could mark the locations where the black holes of the past universe left their Penrose points in the background radiation. However, whether we are truly dealing with a real cosmic tribute is still disputed among scientists. Yet, Roger Penrose remains calm and steadfast in his belief in the idea of a cyclic universe. He answers his critics by pointing out that black holes were once also dismissed as mere mathematical constructs, but as we all know, we are now far more knowledgeable. Who can say which of today's still uncertain theories will one day also become cosmic consensus? And now, you can become a supporter of our galactic substance. Please feel free to click on approval and subscribe so you never miss another video from us again. We'll see you soon.